Welcome to the Spring Boot Plus Firebase tutorial where we create an application or a REST API CRUD application where we use Cloud Firestore, a database by Firebase and Google for our backend, and we see how we can use a cloud database and see how it works. And we can also connect our application with Spring Boot and REST API so that we can manipulate it with using REST APIs. So let's get started. This is going to be a 4 or 5 video playlist where we start from setting up Firebase in our application from scratch. Then we move on to building our APIs, REST APIs, and in the process, we learn how the Cloud Store, Firestore works and how we understand some concepts behind how it's working and such. So let's get started with our tutorial. In this tutorial, we'll be talking about what Firebase is and what Cloud Firestore is, and also do some basic setup where we create our Spring Boot application using IntelliJ, and in the next video we'll take it from there. So first let's talk about what is Firebase and what is Cloud Firestore. So Cloud Firestore is basically a flexible, scalable, NoSQL cloud database where it stores and syncs our data for client and server-side development. In our application, we'll be doing server-side development where we ask our Spring Boot server to actually get data from Cloud Firestore, and then how we can access it, create, retrieve, update, or delete our data. So Cloud Firestore is a flexible, scalable databases for mobile, web, and server deployment from Firebase and Google Cloud. Similar to what Firebase has with real-time databases, it keeps our data in sync across client applications through real-time listeners, and it also offers offline support for mobile and web. So basically, when we create, update, or delete data inside our application, we will be seeing a dashboard where we can actually see our data get deleted live, and all of them will be updated in real time. So we'll see that how that happens and how we can connect our application, a local application, to a server which is given to us by Firebase and Google. So some capabilities that we need to highlight when we're using Firebase is the fact that why it's so famous and why people actually use it for their apps. So the first thing is flexibility. It provides hierarchical data structures, so our data is stored in documents, organized into collections, and then we can make complex nested objects in sub collections, and we can always query them very easily. So it's very flexible to use Cloud Firestore for our needs. We have explicit querying, so you can use queries to retrieve individual and specific documents or retrieve all documents, and this can include multiple chain filters, combine filtering with sorting, all sorts of fancy stuff which you want to do on your database. Next is real-time updates, again a fun thing to see. So we can see it uses data synchronization to update data on any connected devices. So if you have like 10 apps connected to your single Cloud Firestore database, then you can see it updated on all of them live in real time. And it'll be fun to see how that works and how we can actually use it. So yeah, this is basically how it works. So it's a cloud-hosted NoSQL database for all the platforms, and it's available in native Node.js, Java, Python, Unity, so on and so forth. We will be using the Java REST API library and framework to actually query our data, and we'll develop a simple CRUD API. So whenever we learn a new technology, the best way to get started, or the hello world of learning anything about web servers or web frameworks, would be to create a CRUD application in it. It teaches us how to interact with the database, teaches us how the basic functions work, methods work, and also gives us a simple CRUD application at the end, which we always create. So it'll be fun to work with that, and in the tutorials we'll see how everything connects together and how easy it is to actually connect our Firebase Firestore database with our local Spring Boot application. So first I would highly recommend you to go through the documentation. We cannot cover every single thing in documentation in our videos. We'll jump into the implementation directly. So I really encourage you to go to the description of the video and read enough about Cloud Firestore to be comfortable working with it, so that we can have a very good and productive discussion whenever the video is on. So yeah, let's get started. So first thing which we need to do is create a project in Firebase, but before that let's actually create our application, a Spring Boot application, so that we have everything from application side ready. In the next video we can directly continue with our Firebase configurations. So as like any other online API or SDK, we have to have secret keys which we can use from given by Firebase for our application, so that we can authorize and authenticate each and every request it sends, and also basically have all the libraries and Maven dependencies ready. So let's do that boilerplate stuff in this video, and then in the next video we can actually start building some stuff using our application. So here, if you can see the screen, I have a very simple Maven project which has a pom.xml, nothing inside so far, just a pom.xml. So first let's fill this up and let's actually have something inside here which we can use. So to do that, let me quickly get all the dependencies that we need, so that we can then just talk about it and then focus more of our time on how do we actually set up Firebase on its side. So let me just get this done, and once we get this done, let's just quickly have Maven pull them. Might get some errors if it is not properly configured, but I think my environment and paths are correct, so not to worry in that aspect. And yep, I think everything looks pretty good, smooth. Let the indexing and everything get done. Okay, great. So let's go through our dependencies. So since we're working with the Spring Boot REST API project, we will have Spring Boot Starter Web to have basic necessities in terms of annotations which we need to use. Lombok is to make sure that our data looks good, and again annotations which help us help our CRUD API journey smooth with all the annotations it provides. Next is the Firebase admin dependency, which will basically help us interact with Firebase using the underlying APIs, and we'll see how easy it is to actually work with the Firebase admin and see how it works. Lastly would be to have our Spring Boot application use a Maven plugin to install all of our dependencies and just build our project properly. So pretty simple boilerplate code here, nothing crazy that's going on. I would say the next thing would be to have a runner. So if we have a runner, it'll just be easy to run our project from the next time. So create a package and let the name of the package be com.java.firebase. And inside this package, we can have our runner class. We'll have all of our classes here, but let's call it CRUD. So we're just going to build a simple CRUD app, right? So let's just call it CRUD runner. And inside this, we'll just start our application. So all we have to do here is copy a bunch of stuff, nothing crazy. All we are doing here is having a main method. So public static void main string args, and let's call this our Spring Boot application entry point, and have a very simple Spring Boot application runner which basically runs our application. So yeah, this is simple basic information which we need in our application to run it, and we have our pom.xml also set. Now let's jump on to the Firebase configuration side where we need to set up our application. So what do? Go to console.firebase.google.com, and if you don't see this page, don't worry. All you have to do is add a project. So make sure you find that, and from here it will be the same steps which we do. Let's call this Firebase tutorial DB. And let's see how it works. So have a name for your project, Firebase project. This can be disabled for now, and Google will basically create our database and everything for us. So all you have to do is just wait. It takes us a couple of seconds, but if it's taking some more time, then I'll probably wait for a few more minutes and then see if it's happening. Usually it's pretty smooth, no problem here. So yep, we are good to go with our application. And as you can see, we have our Firebase tutorial DB ready, up and ready to use. So in the next video, we'll see how we can actually get all the secret keys from Firebase and set it up inside our local application, so that when we run our application, we connect to the correct database, and also create a database and make sure that everything is smooth in terms of connecting, so that in the later videos, we can then start building our application and building our CRUD endpoints for Firebase. So this is it for this video. Make sure to go through the documentation which is in the description below, to get used to Cloud Firestore, and make sure to follow the steps to create a new Google project, and also to have our pom.xml ready with all the dependencies which we talked about here. So yeah, thank you for watching, and I'll see you in the next video. Welcome to the second video in the playlist Spring Boot plus Firebase to build a CRUD application. In this video, we'll talk about how we can authenticate or authorize our local Spring Boot application to connect to Firebase, and also connect to our database which we create on the Firebase dashboard. So in this video, we'll mainly focus on setting up or connecting our local application using some starter runner code, boilerplate template mainly, to connect to Firebase, and also see how it actually gives us our secret keys. And it's a very fun little way of how they do it. So before we jump to the contents for this video, let's just have a refresher on what we had done previously. So we had set up our basic Spring Boot Maven project where we have all of our dependencies ready, and we also went on and created a project on Firebase using console.firebase.google.com, and we had a very simple project up and running. So in this video, let's actually go ahead with where we had stopped, which was basically this particular dashboard. I'm using a database which I've already created, so it's easier to show how it works. As you can see, I've already done 12 reads and two writes here. So we'll see how all of this looks like. So let's go ahead and then jump into what's next to be done. So now that you've created your Firebase project, we need to connect it to our local application. And for that, we definitely need our secret keys, right? A bunch of keys which we need to connect to our local application. So how do we get them? So go to settings here, project settings, and go to service accounts. So the accounts which we use for our application. And here, what you need to do is go to database secrets. Or you can either go here as well. So HDK, or this is legacy, so not supported anymore, and it's supported to use the admin SDK. So let's go ahead and do that. Here, for any implementation, we have the configuration ready, and we can generate a private key, which is going to basically give us this JSON file. So when we click on generate new private key, it gives us this particular JSON file, which we then save inside our application and load it when we are setting up our runner. So we are using Java. So this is going to be our Java code for our application. It also gives us the database URL, which is our current URL. And we can copy this and put it inside our Java code. So before that, let's just go to generate new private key. And let's do generate key. And this will give us a service account key.json. So yeah, here you go. We have our JSON ready. And all you have to do is just call it service account key. Even if you don't call it that, it's fine, but just to understand what it's doing, call it this and save it inside your application. So where do we actually save it? So we save it here. So go inside resources. It's basically a resource inside our file, and do a new file and call it service account key.json. And inside this, we can put our application. So let me just take out all our files and put it here. So this is basically what's inside my service account key.json. It will be different for you, and this will deactivate until we upload the video. So it has a bunch of keys, email, client ID, tokens, a bunch of certs URLs, certification, all of that inside our service account key.json. Now what we need to do is load that file inside our application and runtime, and then use that to actually authorize our application at runtime, so that whenever we use our application, can directly automatically go and authorize us to use Firebase, right? So let's see how we do that and how do we actually work with this. So first, go inside your main method and do a class loader equal to CRUD runner.class get class loader. So we get the current class loader here, and then we get the file from where we actually want the resource, or we load the file. So what we do is we create a file. Let's import the class. Java IO, and this is going to be a new file, and all we are going to do is class loader dot get resource. And where do we get the resource from? So since it's going to be in the class path, because everything which is under resources goes on the Java class path, all we can do is just do service account key.json, and it will read it for us. Now, uh, once we get this, we need to return the absolute path for this particular file. So what we do is we do a dot get file. Let me just check how this works. Then we can add it inside our application. So this is again boilerplate code which is available there. So this is how it's going to look like. So we have file input streams, we have absolute path, and let's add an exception to our signature, file not found, and yep, simple stuff. So we have our service account here ready, and we get our absolute path. You can do a system.out.println to see how we get the path and where it is actually point to. The next thing would be to copy basically this and paste it here. So let's do that. And once we do that, we will have our application up and running. And we'll go through what's happening in the code as well. So here I have what we use for here. So let's just add our method signatures. And we are good to go. So what's happening here? So we use the Firebase options class, and we set the credentials from our service account, which is a file, and then we set our database URL and we build it. After we build our options, we initialize our applications with those Firebase options, and that basically authorizes us to use Firebase. So this is what's happening and how we connect our project or database with our local app. It's pretty straightforward, pretty simple. Just copy or generate your private key, which gives you this service account JSON file, put it inside your resources folder, and then use this boilerplate code to initialize your Firebase application to authorize Firebase. So we have this done and ready. Now let's create our database which we can connect to our application. So go to Firestore, and here we have our database URL. So we basically have our database up and running. We just need to add stuff to it, right? So here I have a collection inside my database, and let's just create a new collection. So let's call this CRUD user. So basically somebody who's using this application, and document ID is going to be, let's say, user1, and the field is going to be name, and it's going to have a value, let's say Ronak. Oh, sorry, Ronak. Yes. The next thing is going to have is profession. So let's say freelancer, and then we can just do a save. So this is us making a schema or a collection inside our NoSQL database. It has a user1, and it also has 2 fields inside our database. So this is how we created a new schema inside our FireCRUD main database, and now we can connect our application and then basically get this or add stuff to this. So this is our database ready, and whenever we do a create, update, or delete from our local application, we can see that updating at real time in our particular dashboard. So in the next video, we'll start creating our object, our class, our data, and our DTOs for our application, where we can create services on top of it, CRUD services, create, update, delete services, and then actually hit our Firestore database and see how it works. All of that in the next video. So what did we learn in this particular video? We learned how we can create or authorize our local application with Firebase. We had some boilerplate code which basically loads a resources file which has all the secret keys, and then we use Firebase options to connect to our Firebase application and then run it. All of this is done, and then we create our Firestore database which updates in real time, create a new collection, and then we can query our database using the CRUD user collection, and then so on and so forth. So this is it for this video. In the next video, we'll start building our local application so that we can start hitting our Firebase database. So thank you for watching. I'll see you in the next video. In the previous video, we had created our authorization implementation where we had a service account key.json, which basically has all of our credentials and authorizations, and used that to connect to our Firebase account, which is hosted by Google, and a database as well. So let's run our application and first see that everything is working smoothly without showing up any errors for authorizing our application. So we have our application ready. So let's just do run CRUD runner, and that should initialize our Firebase application and also run our Spring Boot application. And hopefully nothing breaks here. So we have our Tomcat server up and running, and let's just quickly do a sanity check. No errors so far, and everything is being executed, and yep, looks great. Nothing broke. So yeah, let's talk about what we are going to do in this video. So we have our local application and it has been authorized to hit Firebase. Now we, for our CRUD application, first we need to do is have data which we need to create, update, or do some operations on. So first let's create our data and then we can do a bunch of things with that data. So go inside your package, new Java class, call it CRUD. So this is going to be a simple data which we can operate on. Let's have our setter and getters from Lombok so that it's easier to work with them. The next thing which we need are a bunch of um, attributes for our data. So here inside our data, we just have two fields. We have the name and the profession, and we have the document ID, right? So let's do that. So let's have all the three here. So we have private string document ID, we have private string name, and private, not private, we have private string profession. So this is basically the attributes which we have inside each document for our CRUD user schema inside our Firebase CRUD main database. So this is how we can access our object in a serializable manner, which gives us these three things whenever we want them. Now this is the data which we'll be working on, where we update, delete, and retrieve this particular in JSON format, data in JSON format. So what's next? Now we need to have a controller which basically talks or shoots out APIs, right? So let's have a CRUD controller. We'll be following the MVC architecture, the model view controller. So we have our controller, we have our view, which is basically JSON, and model, which is going to be Firebase, which is handling our database there. So inside our controller, what are we doing? So we are talking to a service which basically interacts with the Firebase database for us. So let's go ahead and first create that service as well. So we have CRUD service, and this service will basically contact Firebase and get all the data from it or send data to it, and it will be operated on using the CRUD controller. So let's first implement our CRUD controller. So we call it a REST controller, and let's initialize our CRUD service application class first. So public CRUD service, and let's do an simple constructor here called so CRUD controller. Take CRUD service and let this inside this dot CRUD service equal to CRUD service. Okay, simple initialization of our CRUD service so that we can use all the methods and such. Next would be to have our controllers ready, right? So no beans found. So let's first actually create a bean for this. So let's go ahead and make it a service, which will indirectly make it a bean for us to use. And this should go away. If not, then okay, it's gone. Now let's create our API endpoints through which we are going to contact Firebase, right? So we have create, update, create, retrieve, update, delete, right? CRUD APIs. So let's add them sequentially. So post mapping, we're going to do a post to /create, and this will create our CRUD data. It will return the CRUD data created, or we'll just say return the string for now that our data has been created. We can see the data being created on the dashboard, and it will have a request body, and this body is going to be CRUD in the CRUD object form. This throws a bunch of stuff. So it throws interrupted exception and also throws execution exception. So this is for Firebase, so we'll get into that in a minute. And inside this, all we need to do is return CRUD service dot create CRUD, which we are going to make right now. So this is not existing inside the service class, but we will be making this in a minute. Let's do the same for the other endpoints. So we have create, we need retrieve. So this is going to be get mapping, not twice. So we have get mapping and we do get, and we also have the name. So that's going to be a request parameter. So instead of create, we can do get CRUD, and instead of request body, we do request param, and this is going to give out a CRUD object. So get CRUD, and this is going to be string and the name of our application, basically, or document ID is what I would say better. Document ID, and we pass it on to this, and we get our get endpoint done. Let's create the other endpoints. So now the next thing which we have to do is create the update. So create retrieve is done. Next is a put mapping. So let's quickly write that as well. So we have put mapping, and this will update. So let's do update. Again, return a string because you want to see this happening inside the dashboard. Update CRUD, and again we want this little thing inside and not the document ID. So this will become CRUD. Yep, CRUD update is also done, and last but not the least is delete. So let's have our delete up and ready for it to use. So delete delete. Yep, everything looks good. We need to delete by document ID, so let's do that. And this is going to be not delete, it's going to be delete, and we're deleting by document ID. Okay, awesome. We have all the REST controller endpoints that we need to talk to our CRUD service. And next, let's create all these services or the method definitions first before we move on. So first is going to be public string create CRUD, which takes in CRUD and does a bunch of stuff, right? It basically returns, for now it returns an empty string, but it will return something later on. Next, we want the same for delete and update as well. So let's do update first. So update, and okay, so what's the problem here? Request is CRUD, right? So already defined. Okay, my bad. This is going to be delete CRUD, and this should make sure all the problems go away. And yep, almost looks like it. Everything looks good. Delete takes a string, so my bad. Yep, and the last is going to be get. So we do get, and this is going to be string, not in German, document ID, and we are good to go. So now we have our function definitions, what they do. Pretty straightforward, they don't do much for now. It's just simple enough to get it working. And we have our CRUD controller ready as well. So hopefully the errors go away. Yep, and they did go away. So yeah, we have our REST controller ready. Usually I do a simple unit test to check whether a controller is running or not. So the way I do that is basically have a test endpoint which does it for me. So let me just show it to you right now. So here I have a /test endpoint which basically gives me that the test endpoint is working and gives me that my application is sane. So let's actually, see what's happening inside slash test so that we make sure that our application is up and running. So let's run our application, and hopefully we will have a simple uh, app ready without any hassle. So our server is running. Once it's done, we can then use anything to run our application. Basically, just do a slash get, right? So it is on port 8080. So let's do it here. So let's do local 8080 slash test, right? And we get the endpoint is working, so that's good to know. We have our application up and running. So in the next video, we will actually implement the main logic of our application, where we actually talk to our Firebase database and then we create our endpoints. So thank you for watching. I'll see you in the next video. In this video, we'll talk about how we can create a CRUD service and connect our local Spring Boot application to Firebase and do some operations on top of the data which we have stored in Firebase and Firestore. So welcome to the fourth video, where we almost finish building up our CRUD API using Firebase and Spring Boot. And once we get done with this, we will have a fully functional CRUD API application up and running, which contacts Firebase. So let's get started and let's start implementing our CRUD service, where we actually use the Firebase APIs and connect to our database and do a bunch of stuff. So let's start implementing. So first we implement our create APIs. So let's start with that. So we have Firestore db Firestore is equal to, let's import the classes which we want. So it says no Firestore is available. Oh, my bad. I should spell it right. Yep. Great. So we have Firestore, db Firestore, and we use the Firestore client dot get Firestore. And since we have already configured our application using the service account key, we don't have to worry about authorization anymore. Our app is automatically authorized. So that's a great thing to need to know. Let's have some boilerplate code here. So collections API feature, and this is going to be equal to db.fb db firestore.collection. So which database are we trying to get our data from? So this is basically our database inside Firestore. So if you go inside that and if you see our collection, so we have two collections here. The first collection was made before the videos users, and we are using CRUD_user. So let's call this CRUD_user. So inside this particular collection, we want to create a document. So we do .document, and here we create our document. So let's actually create it. So we do CRUD.get name, and we do a set, and it's a pojo. So we have our CRUD name right here. And now that we've actually set or committed to our database, let's send back the time when we did this, when we get the result back. So, and we'll convert that to a string. So return collections API feature dot get, right? So we do a get update time dot to string, and here we have created our create CRUD, or implemented our create CRUD functionality. So what's happening here? So first we connect to our database using our credentials, which is happening behind the scenes when we initialize or we get the Firestore from our account. The next thing that's happening is we're using API features to actually connect to our CRUD user and then just do a set of CRUD, and that's basically as simple as it can get when it comes to implementing our API. The next thing would be to implement get. So once we have created it, we need to get it. So let's actually implement our get API and let's see how that works out for us. So how do we get it? So the first thing which we do is the same as create CRUD. So we connect it here. You can obviously abstract it out inside CRUD service, but let's just use it for easier purposes here. So we do a document reference. So basically look up inside our document and which document are we trying to reference, right? So we db faster dot collections again, give it a collection, so user underscore name, and we do document and we want it by document ID, so document ID, and that's how we want our document. So once we get our document reference, the next thing which we want to do is actually get it from the API. So for that we'll be using API feature document snapshot, so document snapshot, and this is going to be a future value which you're going to get from document reference dot get. Awesome. So now we have a snapshot, and from the snapshot we want our from the API feature we want our document snapshot. So let's quickly write the code for that. So this goes away. We have our document snapshot, not a feature that we want, and this is going to be our document, and we are basically going to do what we did above. So we do a future.get. So as you can see, a lot of abstractions that we have to deal with here. Add the exceptions, and yep. Now once we get the document from Firebase, we need to convert it to a plain old Java object, so Pojo, right? So let's do that now. So let's have a CRUD app, and the next thing which we have to do is check if the document exists. So if document exists, then what do? We do CRUD is equal to document.to object. Pretty simple. CRUD.class, and that way we return CRUD. Perfect. And if it doesn't exist, then we return null. So that's basically how it usually is. So we first connect to our Firebase client, and then we connect to our Firestore client, and then we get our document, we get the document reference, the snapshot, and then the document snapshot back from the API feature. We convert our document inside to object from a Pojo, and then we send it back to the user. So that's how we implement the get CRUD API. More information can definitely be found on the website in the description below. And let's implement delete. So once we get our data, we can delete it. So how do we delete it? Again, pretty much the same as before, but slight changes. So let's talk about them. So instead of doing a document, we do a document ID, a name, so ID dot delete, and as simple as that, we are good to go. And we don't have to do anything else here. So this is just going to be write result, spell that correctly, and this is going to be API future write result, which we get back, right? And the next thing which we have to send is basically the document ID. So successfully deleted space document ID, and yep, we are good to go with delete as well. So this is how we implement delete, get, and create. So let's quickly see if we have something here. So we have a document ID as user underscore one. So when we do a get after running this, we should be able to get that back, and it should be converted into a Pojo, giving us so what is it giving us? It's giving us document ID, name, and profession. So we should get that back when we run it. So let's run it and see what happens. Do we actually get it back, or not. So this is going to be CRUD user, my bad. Again, CRUD user, because that is what we have our collection as. And let's run the app and see what's happening. Let's open up Postman as well so that we can do our queries and our API, hit our APIs. So we have that here. Pretty interesting thing. And let's wait for the server and Postman to be up and running. It always says a few minutes, but never actually takes a few minutes. So that way, you expect that you're expecting it to be minutes, but they give it to you in seconds, and you get this dopamine hit that Postman is fast. So that's how they get to you. But anyway, apart from that, we have our server running. We have Postman setting up, so it actually is taking minutes. That is weird. So we have some time till our server runs, and until then Postman hopefully should be up. If not, then we can obviously use, we're doing a get call, right? So we just use the browser for that. But let's give Postman some time. The server is up and running, so yep, Postman is also up and running, and it did take some time to do this. So what are we doing here? So we're doing a get CRUD, right? So let's quickly see that inside our controller. So we are doing /create. Okay, we're just doing a /get. No, a get CRUD. So we do a get, and here the key is going to be document ID, and the value is going to be what? User underscore one. User underscore. And this, when we do a get on this, we should be getting back our data. So document ID is not present. Okay, I get what's wrong here. Let me quickly fix that. So close this down, go to inside CRUD, and this is document ID. So what was the issue? It gave a bad request, right? And what was the bad request? Required string parameter document ID is not present. So it needs a string parameter which was not present. So CRUD controller document ID. Oh, my bad. I think I know what I did wrong. Yep, I spelled it wrong. So let's run the server again. Should be up because we didn't do any changes. And all you have to do is just have to be document ID. My bad. And almost we are good. We're done. Server is up. Do a send. And let's see what's up. So initially it does take some time, and as you can see, we have our Ronak Vyas and freelancer professor here. So perfect, it was working. And the next thing which we need to do is implement our update API and also test our application and see if it's working perfectly or not. So thank you for watching. I'll see you in the next video. So in this video, we will be implementing our update service, and we will be testing our Spring Boot and Firebase application, and we'll be doing a full end-to-end test where we create, update, delete, and retrieve from our data. So first, let's jump and quickly start with our update CRUD function. So let's quickly jump into that. So update. So how are we updating? We do firestore db firestore equal to firestore client dot get firestore, initialize our firestore, do an API future with write result, which is basically going to be collections API future, and this will be equal to db firestore dot collection, which is going to be CRUD user dot document dot dele delete. Great. So looks good. Looks pretty straightforward. And instead of delete, all we have to do is update. So for update, it's basically going to be the same as create. So if we do crud user singular, and see, we just do a get and set, so it just overrides and updates whatever is missing. And same as create, we give out this so that it knows what it should expect. Add our method signatures to it, and we have our update as ready as well. Okay, so we have some discrepancy here which we need to fix. So document ID needs to be document ID, not something else. Everything else looks good. Card, document ID, everything is looking great. And okay, yeah, the next thing all you have to do is console, not that, and all you have to do is run our application. So let's run it and let's see it from the beginning, where we do a create, update, delete, and get. So definitely write unit tests for your application, and we'll talk about unit tests in the next playlist, where we start from simple unit tests, we move on to controller unit tests, and then also mock, see how Mockito works and when do we actually have to mock our services. And from simple unit tests, we will jump on to integration tests and see how all of that works together. So pretty interesting playlists coming in the future, but for now, let's test our CRUD runner. So let's do a get, quickly do a get and see what's happening here. Take some time. We did a get. Let's do a post, and let's do a create. Have a body. Body is basically going to have document ID. It's going to be user2. It's going to have name. It's going to be another, or let's just say programming knowledge. And the last thing is going to be profession. So profession, and we can call this as YouTuber. And yep, so let's do a post and see what's happening. Do a send, and we get back the time. And if you see Firestore, it has automatically updated it to programming knowledge. Document ID is user2, and this is all looking great. So what's next? We did a create. We did let's do an update. So let's call this YouTuber plus software developer, and all you have to do is make it a put, update, and hit send. We get back this, and as you can see, we have YouTuber plus software developer. So put also works, create also works. We did a get, so let's do a get again. So we do a get, no body, params is going to be document ID, which is going to be user2. Hit send. Got nothing, so I think doesn't exist. Let's call this programming knowledge. Hit send, and yep, we have this. So I think it's using the name and not the document ID here, so I need to check up on that, but you know how it works. And yeah, the document ID here is programming knowledge, so something to change in the code for that. Let's quickly see what was happening. So we do a get name, and so we're setting it by name and not by document ID, so that's what we did. So if we do a get document ID and then set our CRUD, that is where it actually does it properly. So same thing which we did here, we do the same thing for update as well. So update CRUD, instead of get name, we do get document ID, and that is how we update, delete, and create it. So that's more or less how the CRUD API works. Let's go through the beginning and see what we had implemented. So we started off with our pom.xml, where we added some dependencies like Spring Boot Starter Web, Test, Lombok, and Firebase, which is basically how we connected to our database. Here we then went to project settings, and that way we created our service account key and private key in service accounts. We took some boilerplate code here for the Java authentication, where we extract a resource and then implement it or integrate it with our application in Java. Next was creating a Firestore database. We created a collection, which was basically a schema in NoSQL called CRUD user, and then we had some attributes added to it, such as document ID, name, and profession. Now, when we come back to our application, we went to the CRUD runner and we added our boilerplate code to have the authorization done and connect to our database URL, initialize our Firebase app, and have our endpoints up and running. So our endpoints are create, retrieve, update, delete, and a test get endpoint to see if our endpoints are working properly or not. We then used a CRUD Pojo, which basically is how our data looks like in this database, and then we just mapped it to it so that we can see our application do stuff. Last was the CRUD service, where we implemented all of these and connected to our Firestore Firebase database application, and that way we were successfully able to create, update, delete, and have a fully fledged CRUD application with Firebase and Spring Boot up and ready to go. So what next? So we end our Firebase tutorial here and playlist here, but the next set of tutorials will include, as I said, unit testing, where we start from what unit tests are, why do we need them, how can we actually use them in interviews, and also talk about how are they implemented in Spring Boot, and also then move ahead with integration tests and explore the entire testing pyramid for our better understanding. So thank you for watching, and I'll see you in the next video and playlist.